Okay, recording now. So we will balance this equation by the half cell method in the basic medium. So the first step always is to find the oxidation numbers. So we have the oxidation number for oxygen is known, but the oxidation number for nitrogen and manganese can be tricky because they can give you more than one type of charges. So manganese, MnO4-1. Oxygen is always -2. So there are 4 oxygens. So 4 times -2 is equal to -1. So X minus 8 is equal to -1. X minus 8 plus 8 is equal to -1 plus 8. So this becomes +7. So manganese has the oxidation number of +7. Okay. Next, in MnO2, let's get us here also, MnO2. Now, this is a neutral molecule. So X again for manganese plus 2 into -2. For oxygen is always -2, and this is equal to 0. So X minus 4 is equal to 0. X minus 4 plus 4 is equal to 0 plus 4. So therefore, the oxidation number of manganese is equal to +4. Now let's look at for NO2-1. So for nitrogen, X for nitrogen plus 2 into -2 is equal to -1. And here you have X minus 4 is equal to -1. X minus 4 plus 4 is equal to -1 plus 4. So X is equal to +3. So in other words, the oxidation number of nitrogen is +3. The other species is the nitrate, and we already calculated it earlier, but let's do it again. So nitrate -1. So nitrogen is X plus 3 into -2 is equal to -1. X, 3 2s are 6, -6 is equal to -1. X minus 6 plus 6 is equal to -1 plus 6. So what do you have here? So this is nitrogen, here is +5. So what is happening? Manganese going from +7 to +4. So what happened to manganese? Manganese got reduced, right? So manganese got reduced. And what happened to nitrogen? Nitrogen went from +3 to +5. So what happened to my nitrogen? It got oxidized, right? This much is clear, everyone? Just counting the oxidation numbers. Clear, everyone? Yeah.
Like when you do manganese, is that like why aren't you doing it for oxygen?
Oxygen is always -2. That's the rule, right? The oxidation rules always -2, except when oxygen is in peroxide. Peroxides, you can't miss peroxide. Peroxides are like H2O2, Na2O2, like that. That type of formulas will be a peroxide formula. So in a peroxide, oxidation number of oxygen is always -1. Otherwise, always oxygen is -2. That's given. Okay, clear? So manganese, why we are doing for manganese? We are doing for manganese and for nitrogen also, because manganese is present in group D, in the D block. If you look at the periodic table, you will see that manganese is present in the D block side. So here manganese, in fact, its number is 25, atomic number 25. So it's in the D block. So these guys can give more than one type of positive charges. Many of the D block elements will give more than one type of positive charge. So there, we don't know which one is it. Is it +2? Is it +5? Is it +7? In fact, manganese can also form +4. So many types of charges are possible because they have the d orbitals in which the electrons, we talked about hybridization, right? Electrons jump internally and they spread out, and all this spreading out creates more opportunities for them to make more types of bonds. So as a result, manganese But we don't know in this reaction whether what charge is on manganese. So we need to find that charge. Oxidation number is actually charge only. Okay, got it? Okay. So that's a good question. So now we identified the oxidized and the reduced. Okay. So guys, just if you guys have any doubts in these steps, you're like lost a little bit, please don't hesitate to ask me. Okay. Okay. Next, number 2. Now you break up into the oxidized and the reduced. Break up into the reduced cell and the oxidized cell. So reduced, let's put it here, reduced and oxidized here. Okay, break it up into 2 cells. So you're going to put the, which one was that? MnO4 minus 1, MnO4 minus 1 is going to MnO2. I mean, if you look at it this way also, it is reduced. It has less oxygens, right? The previous one has more oxygens. MnO4, more oxygen. So loss of oxygen is reduction. Nitrate, look at this. Nitrite, NO2, less oxygens. Going to nitrate, more oxygens. So oxidation. Clear? Just by looking at that also you can tell. All right, guys? Now, once you break this up, what are you going to do next? Balance the metals first. So that's the first step. Here we have 1 manganese and 1 manganese on both the sides. So manganese is balanced. So the second one, we don't need to here. There is no metal. So leave as it is. So as it is. So no metal here. So here we are going to keep as is. Nothing is changing. Okay. Next step. What are you going to do next? Balance what? Balance the, what else is there? Manganese is balanced. What else is there? What is there? Oxygen is there, right? So manganese we already balanced. So what is not balanced? What is not balanced? Oxygen. How can you balance oxygen? By what? Adding water. Okay. Don't do the molecular balancing in this case, like you put 2 in front as a coefficient. That's not how we are working. We are going to balance the oxygen by adding water in this case. Okay. What about here? How are you going to balance the oxygen? Oxygens are also not balanced, right? Nitrogens are balanced. So in this case, let's just put it here. Nitrogen is balanced, but what about oxygen? How will you do? Same thing, water. Very good. So don't be afraid, you know, it's just water you need to add. That's it. MnO4 minus 1 gives you MnO2. How many waters will you add? How many waters? 2. Why 2? 2 is correct, but why 2? Because the focus is on oxygen only. Don't think about like hydrogen or anything at this stage. Our focus is right now, we are only focusing on 4 oxygen. So 2 are coming from here and 2 will come from here. You get that? So don't think about hydrogen at this stage. Next thing is the other one. NO2 minus 1 plus H2O, correct? And that gives you NO3 minus 1, correct? So here also, you will see that 3 plus 1, no, sorry, 2 plus 1 is 3, and that is 3. Oxygen balanced. Clear? What's the next step? Very good. Balance hydrogens. And how do you do that? Hydrogen ion. Excellent. So how many hydrogens are on the manganese side, permanganate side? No, total hydrogen. How many? 4. So these 4 hydrogens have to be balanced. So you're going to put 4 hydrogen ions, okay, plus MnO4-1 gives you MnO2 plus 2H2O. Clear? In this case also, let's look at this. We have NO2, right? In this case, we have 2 hydrogens on one side, NO2 minus 1, 2 hydrogens. So we are going to bring 2 hydrogen ions on the other side. So NO2 minus 1 plus H2O gives you NO3 minus 1 plus 2 hydrogen ions. Clear? So here, in this case, if you look at it, the 2 hydrogen ions and 2 hydrogens balanced, 4 hydrogens and 4 hydrogens balanced, correct? Now, what are we going to do next? We are going to look at the we are going to balance the charges. Now, let's look at the charges. In this case, here we have, okay, let's do this here. We have 4 plus 1 charge, plus we have 1 minus 1 charge. This is giving you 1, 0 charge, plus 2, like 0 charges, right? So we have 4 plus 4 charge minus 1 charge. So that becomes what? Plus 3 charge. But the other side is 0. So we have to make it, so in a reduced side, you put it on the left side. So if you put 3 electrons plus 3 charges were there already, that's going to make it 0. Clear? 3 electrons always means 3 minus 1 charge, okay? Plus 3 is equal to 0. Or in other words, minus 3, so this is minus 3 plus 3 is equal to 0. So this is how it manifests, okay, the charges. Clear? Okay, let's look at the other side. Okay, here you have 1 minus 1 charge plus 0 gives you 1 minus 1 charge plus 2 plus 1 charge. So here we have minus 1 plus 0. Okay, and this is equal to minus 1 plus 2 charge. So this becomes minus 1 here and minus 1 here. All right. Did we get, oh no, wait 1 second. So minus 1. Oh, wait 1 second. It should be a plus 1. Sorry. Yeah, it's a plus 2 minus 1 is plus 1 charge. So how can you make it minus 1? Remember, for the oxidation, we have to add the electrons on the right-hand side. So how can you make this minus 1? No, 1 electron. Sorry, no, 2 electrons. You're right, 2 electrons. 2 electrons, yeah. So we are going to have, we have minus 1 here, and we have plus 1 and plus 2 electrons. 2 electrons would mean plus 1 here, plus this is the 2 times minus 1 charge. So this becomes plus 1 minus 2. So that gives you minus 1. Yeah. Okay. Now, make it smaller. Okay. So now we have seen that this side we added how many electrons? We added 2 electrons on this side, but this side we added 3 electrons. Remember? So 2 and 3. What is the common multiple for 2 and 3? 6. So what will we do now? So just bring back all of this down here. So this is number 5. So here, let's write this here. So we have, wait a minute, 3 electrons. 1 second. So 3 electrons plus 4 hydrogen ions plus MnO4 minus 1, and that gives you MnO2 plus 2H2O. So this is one piece. The next one here on the other side is NO2 minus 1 plus H2O gives you NO3 minus 1 plus 2 hydrogen plus 1 ion plus 2 electrons. So we have to balance these 2 electrons and 3 electrons. So what do? We have to make them 6. So what are we going to do? Yeah, so multiply by 2 and multiply the other thing by 3. So here, this whole species, everything here is going to be multiplied. So 2 times. And this piece right here is going to be multiplied by 3. So let's do that. So this becomes 3 2s are 6 electrons plus 2 4s are 8 hydrogen ions plus 2 MnO4 minus 1 gives you 2 MnO2 plus 4 H2O. The other one is 3 NO2 minus 1 plus 3 H2O gives you 3 NO3 minus 1 plus 3 2s are 6 hydrogen ion plus 6 electrons. Okay? Clear? All right. Let me just move it here. So this is what we have. So at least the electrons are balanced. So they can be cancelled out. But remember, this is in the basic medium. So what are we going to do? Now, in this step, you are introducing the OH ion after you balance out the electrons and everything. So pretty much electrons cancel out. Now, you can only focus on the hydrogen ions and the water and OH ions. So introduce, let me write this here, introduce OH ions on both sides in the reactants and products, both the cells also, okay, in each cell. Okay, so let's do this now. Okay, 6 electrons plus 8 hydrogen ion. How many hydrogen ions did we add? How many hydrogen ions do you see? 8. So how many OH ions are you going to add? 8. As many hydrogen ions, as many OH ions. Simple, right? So this thing, this, and then the rest of it is just introduces plus 2 MnO4 minus 1 gives you 2 MnO2 plus 4 H2O plus 8 OH minus 1. So that's on both the sides, 8 OH on both the sides. Okay. Now, what do you see in this case happening? This piece becomes what? Oh, why did I not put 8? So this is 8. Okay. So what is this becoming now? What does this become? What about the rest of the class? What does this become? 8 hydrogens and 8 OH. When they meet, what do they form? And how many H2O? 8. Very good. So we have now 8 H2O. Now see how everything cancels out. Now you see you have 8 OH on 8 H2O on this side. How many H2O do you see on this side? 4. So can they cancel out? No. Yes or no? Opposite side. Oh, yeah. Opposite side they can cancel out. Okay. So 8 and 4 will cancel out. So cancel out. Oh, sorry. because they are on the opposite side. Cancel out water on opposite. I mean, if you don't do it now, you have to do it at some point in the, it's best to cancel these out. Okay. So now we have 6 electrons. So let me just do this. So 8 and 4, when they cancel out, how many left now? 4 H2O, 4 H2O. So 8 minus 4 is equal to 4 H2O is left. So that's what you are going to now add. So simplifying. So 6 electrons plus 4 H2O, okay, plus 2 MnO4 minus 1 gives you 2 MnO2. Water is gone, plus 8 OH minus 1. Okay. Clear? Now, the scenario is the same on the other side also. So this is just hold on to this one. This is one piece. This is from one side. And then the other one is the other one also. You will have to introduce the OH. So let's bring the other one. So the other one is 3 NO2 minus 1. Okay. Plus 3 H2O. Okay. Gives you 3, sorry, let me need some space here. 3 H2O. 3 H2O plus, okay, on this side, how many hydrogen ions are there? How many hydrogen ions on this one? 6. So how many OH ions will you add? 6. Simple. So now, this is not, okay. Okay, now let's just focus on this one. So we need, let me grab this. So let me write this down. It's plus 6 OH minus 1 plus 3 H2 gives you 3 NO3 minus 1 plus 6 hydrogen ion plus 6 OH ion plus 6 electrons. Okay, now, all right, here, what do we see? This folks are going to give you how many water? 6 H2Os. Okay, 6 H2O and how many water on this side? 3. So 6 H2O. So 6 minus 3. Remember, this is big, this is small. So this one is going to be 3 H2O on this side. Okay, so we see that in this case, this water and this water here, the common, 3's cancel out, and now we are only left with 3 H2O. So now we rewrite the equation, which is 3 NO2 minus 1 plus 6 OH minus 1 gives you 3 NO3 minus 1 plus 3 H2O plus 6 electrons. All right. Now, this is the whole scenario with the, this one is the oxidized. No, this one was reduced. Yeah, reduced, and oxidized was the nitrate. Yeah, so this is oxidized cell. And this is the reduced cell. And now you're going to add the two. Okay, and now add. Any questions? Yeah, let me just make it like this. Yeah. Any questions? All good? All right, now just add. Now we have 7th step. Okay, so let's bring this out again. 6 electrons plus 4 H2O gives you 2 MnO4 minus 1 gives you 2 MnO2 plus 8 OH minus 1. Here you have 3 NO2 minus 1 plus 6 OH minus 1 gives you 3 NO3 minus 1 plus 3 H2O plus 6 electrons. All right, now you add the two. Okay, so look at the common species, 6 electrons, they'll be canceled out. What else? You have 3 waters and you have 4 waters on one side. So that's going to reduce. And then you have 8 OH on one side and 6 OH on one side. That is going to be canceled out. You see that now? So 6 electrons and 6 electrons completely gone. 3 water and 4. So this is 4 minus 3 is equal to 1 water will be left. Okay, 1 water is going to be left. So that's one piece. 6, so here also 6 and 8. So 8 minus 6 is equal to 2 OH is left. Okay, the rest of it is the same. You can just copy this down. So we have 3 NO2 minus 1. Okay, plus 1 H2O plus 2 MnO4 minus 1. This gives you 3 NO3 minus 1 plus 2 MnO2 plus 2 OH minus 1. All right, guys. So 3 NO2 plus 5. Oh, wait, 1 second. It's coming out to be, did I make a mess here somewhere? It's coming out to be 5 H2O. No, it should be 1 H2O, right? It should just be 1 H2O, not 5. Did some people getting 5 H2O somehow? Huh? It should just be 1, right? Yeah. I don't know from where did that come out. No, anyway, so we have next is MnO4 minus 1, 2 MnO2, and then 3 NO3 minus 1 and 2. Okay, so that is your correct answer. Okay, this is your answer, but it's always a good idea to check also, just so we know we haven't made any mistake somewhere. Check, and then we will be done. Okay, so let's look at the thing on the reactant side. Reactant. Now we are going to look at the reactants and the product, not on the oxidized and reduced anymore. Reactant side and product side. The charges should be the same. Okay, product, DUCT. Okay, now here we have 3. So NO2, so 3 NO2 minus 1, and then you have H2O, and then you have 2 MnO4 minus 1, and then here you have 3 NO3 minus 1, you have 2 MnO2, and then you have 2 OH minus 1. Okay, so let's look at this. So 3 times minus 1 is minus 3. Water 1 times 0, this is 0. And then 2 times minus 1 is minus 2. So this gives you what? Minus 5, right? Product. So this is 3 times minus 1 is minus 3. This is 2 times 0 is 0. And then this is 2 times minus 1 is minus 2. So this side also is minus 5. Okay, so this is correct. All right, guys, got it? So quite quite extensive, and I understand it takes like maybe half an hour, 45 minutes more to do these, but it's worth it. It's worth it. It's all electrochemistry, so you will know it. You will need all this information. So please practice it. Okay. All right. So I'm going to just end this here. Okay. So